Welcome to another episode on my Raspberry Pi 1B. Running Raspbian Linux and connected with this recording laptop through Tiger VNC. In this experiment I focus on reading analog signals into the digital Raspberry Pi, and the last couple of episodes I focused to find out why the analog to digital converter located here gave all zeros, and last time I did some more tests and concluded finally that the converter must have gone broken, gone defect, whatever you call it. I managed to get a replacement, which brings me to the following. Why did it go broke anyway? Why did it go defect, out of function? I still don't know. The point is that the way it was delivered to me was an ordinary plastic bag with some more devices in it, and I can show you the device with, or the bag with all the other components. In this it was delivered to me, nothing wrong with it. The question that it raises to me is, how about the electrostatic discharge? ESD for short. Everyone is electrostatically charged, and electronic components like an integrated circuit such as this one is can be assumed to be statically sensitive. While such a component may work for a while, it may eventually go defect. So now I have decided to put it back into place, the new one. It is not put into the breadboard yet, but I decided to use an electrostatical discharge unit to ground myself and to make sure that that is in no way the case, or that ESD or static electricity will be in this case no more the cause of the converter going broke, or defect. So now I am grounded, and I will have to try carefully to put it in its place. And by the way, here this wire is the power, the 3.3 volts power. So whatever I do now, it is not connected. Nothing will happen yet. So I have to be careful not to bend any pins. One is a little bit bent, but it should be alright. I have to put it quite carefully. And that doesn't go without problems. So I have to bend some pins like this, and one like this a bit, bend them inwards, and I am now grounded, so no harm done. Put it carefully in place again. And then hopefully it will nicely sink into the breadboard. And that's it. Now it's placed and everything is where it should be, or at least I assume it is. Every wire is still in place. I did replace the original 10 kilo ohms resistor by this pot meter, which is now set to 10k, and I'm not going to replace it again with a 10k resistor. Then something is failing here, and that is an LDR, the light dependent resistor, to which it all is about. So now I have from the same package the LDR, and now I have to put it between here and let's just say here. Oops, very thin wires. This won't go. This will go. Alright. So now, when I put power on it, it should work. So let's check it out. So, taking the power jump wire, put it in. Now everything is powered, but not running yet. And here everything is set to SPI. So whenever I now start this program, things should be visible. SPI open 1.1, 1.1. Yeah, that's a reminder from my last test. Still not solved. Ugh, that is a disappointment. That is a very big disappointment. I would have expected at least something, but it doesn't do anything. Why doesn't it do anything? Should I use a 10k resistor after all? I don't think so, because this doesn't matter. And this could be in here, but it doesn't matter. It should work. So why doesn't it work? Firmly connected. Let's try again. Or is I did adapt my code, is my code really good? So SPI open 0.0,0. This doesn't matter, not for now. LDR channel is 0. LDR channel is 0. So what I am going to do is comment everything else out of the equation. And I will only have the LDR value which is needed. And then I can of course also test for these two LEDs. If they function, everything is okay. Well, on that perspective then. Yeah, alright, that is working. But the LDR is missing. Ah, right, I commented out too many things. So this one has to go. And that one has to go. Another try. LDR value 0. Totally 0. Let's bring some more light. Alright, let's remove some things then, although it doesn't really matter. It doesn't matter if I remove things, because they're not being dealt with anyway now. So this once again doesn't go as expected. And this is a brand new chip. And to refresh memory, this is the schematics. Well, the fischertechnik is in a different model now. I could take it out, but when this one doesn't do anything, this one won't do a thing either, because they're on the same channel. So why is this? No. Right, go. Is this because of the resistor? I can't imagine, but suppose. In that case, I will replace the pot meter for the resistor. So what I'm going to do is with putting this 10k resistor in place of this pot meter. And first I will disconnect everything from the power. Take this one out. Put this one in place between power and LDR. So this is the original situation. And put the power back in place. Alright, that should do it, hopefully. So, now what? Run it. Well, and once again, except for the wiring PI with this pulse modulation, it doesn't work. It still does not work. And not just on the oscilloscope, not on the output either. So the question is, what's wrong? Is it something on the Raspberry Pi? Because that is the last, very unlikely, but the very last idea that I have. Except for some mistakes, but I can't see that I made any. Let me unplug the power and let me take out this chip once again. No, not once again. Let me just unplug it nicely with a very small screwdriver. And if the pins are as they should be, then in any way that is not the mistake. Well, they look absolutely fine to me. So it is nicely going back in place. Alright, and power is going back. So the very big question is, what is the cause? Should I have removed this pot meter in the first place and put the 10K in place? No, that shouldn't have mattered, because this is just a 10K pot meter, maximum 10K. That doesn't matter. So right now I'm quite puzzled. An alternative would be to buy another chip, but then again, why would this bell be broken in the first place? Or did I make the mistake that they sent me an old kit? No, because everything looks brand, the resistors look brand new. This is really a new kit. Maybe defect on arrival, could be. But this is a strange thing. Back when I started with the project, it worked flawlessly with one and with two LDRs, and now it doesn't work at all. I have to reconsider everything, and I don't like that. Ouch. Alright, next attempt is to run that specific program that I had to test. And as expected, it gives all 0. Then there's another test, and that involves putting 1K resistor, this one, between the MyCell and MOSI. So bringing back this one, there is MyCell and MOSI. I should improve the schematics, by the way. Anyway, it is about these, I think, yeah. Master output, slave input, master input, slave output. And then I should get a value. If. And that is a very good if. What if it doesn't work? Well, there's only one thing to do, and that is try out. So, first make this one ready for use, like this. Take off the power. And then I will have to be very sure that I'm taking the right ones. And that should be this one and this one. And then the resistor in between. It's very close to each other. And put the power back on. But before I do that, I want to be absolutely sure that this is the right wiring, which is between the third up and the fourth up. I need to be definitely sure. So yes, that is very good. Pins 11 and 12, MyCell and MOSI, and that is exactly what it should be. So, powering up and see whatever the program brings. If anything. Nothing at all. That's no good. Nope. Even worse than the first time. So I'm seriously thinking this is a defect on arrival. Unfortunately. I have to take care of this wire. Now it's back in. Not that it matters, but yep, with my own program, still absolutely nothing. And well, just for explanation, this one is high because it's a negative, it is this negative line. 0 becomes 1, 1 becomes 0, and since this is 0 inverted, it is 1, and the rest is 0 as well, which is understandable because of the 0 values. So where does that bring me? Nowhere. So what's up next? Well, reporting a received kit as defect on arrival. Well, concerning at least one chip. And finding a replacement. It seems there's AVR tiny chip, with tiny being the brand name or something like that, or model name, that has kind of the same function. It seems to be used on Arduino, so if it is nicely priced, I might do that, and in the meantime waiting for a response or whatever the reaction will be. Anyway, useless to carry on. In the present situation, nothing works. Well, the only thing that works is the LED software pulse modulation. And that is the only thing that indeed works. Blinking LEDs. So, rather disappointed, although I'm happy that my RaspberryPi didn't reboot. Working with ESD to avoid any complication, and meeting with this problem. Thank you for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. You can also follow me on Twitter, retweet and like. Twitter has a live link to my video. And on Instagram, follow me and like. And Instagram has a passive link to my video, because Instagram doesn't allow video links or links at all, but nice pictures. Please donate to keep videos coming to you. More information on my website, apart from information on lots of other stuff, and this is going to be continued whenever possible. For now, bye bye.